Now let's take a look at how to make decision about the claim. There are a few things that we need to discuss. One is the so-called traditional method. In here, you need to find critical value and critical region. Critical value, the critical region is also called rejection region. And secondly, we need to look at a p-value method. And the last one, the confidence interval method. 3 ways to make decisions. Let's first look at the traditional method. The traditional method involves finding the critical value so that we can find the critical region, and then if the test statistic is falling into the rejection region or critical region, we are going to reject HO. Now let's assume the alpha we're going to use for the following example. Several slides is 0.05, so alpha is 0.05. And let's take a look at the first example. This is a right-tailed test. How do I know? Because this is greater than. I really don't care what this symbol is and what this value is. The idea is the same. Now the reason I choose a P here, because we do know from previous the test statistic, when you test the P, the population proportion, Z statistic is involved, which means standard normal distribution is involved. This 0.7 is you can use that when you find the critical, compute test statistic. But when you find the critical value, in this case, this is really, it doesn't matter. All it matters is this guy, okay, the greater than. Let me show you how the process. First of all, because I know this is testing P, population proportion, it involves the Z statistic. I'm gonna draw a bell-shaped curve because it involves Z statistic, which is standard normal. And this is right-tailed test. That means you're trying to test whether the P proportion is to the right of this guy. If it is really to the right, then you can reject HO. You're gonna say H1 is supported, right? So therefore, the rejection region, the rejection to reject HO, the P should be to the right. Now, to the right of what? To the right so that the P is falling into this area, and this area is 0.05. Why 0.05? Because alpha is 0.05. If alpha is 0.01, then this shaded area should be 0.01. It really depends on the alpha. So now, this is the value we are looking for. This is so-called a critical value. How do we find that? If you can recall, this is a standard normal distribution. You know the area. You should be able to find the value. Now I'm going to show you on stats crunch, okay? Now if you can recall that the graph I drew, it was very similar to this one. And so I first draw the bell shape, and I show that this is 0.05. This is the alpha. That's why I type in 0.05 here. And this is to the right side because it's right tail. That's why I choose the greater than or equal to and then compute. This is 1.645. Okay. So therefore, this is what I have. So in here, you can see that to the right side, this is called a rejection region. Okay, if you have a test statistic, the test statistic is falling into anywhere this region, you're going to reject your HO. If your test statistic is falling into this region, you fail to reject HO. So you can see the region for your decision. Now this is a left-tailed test. Okay, left-tailed test. Similarly, to find the left-tailed test, the critical value and critical region, draw a bell shape. And this area is 0.05 because we assume alpha is 0.05. And this is the critical value we're looking for. And to the left side, this is the rejection region. To the right side, it's non-rejection region. And it can be found in a similar way in StatsCrunch. It's negative 1.645. So this side, this is the rejection region, or the so-called critical region, and this is the non-rejection region. If your test statistic falls in this region, you're going to reject the HO. If your test statistic falls in this region, you fail to reject HO. Lastly, this is a two-tailed test. For two-tailed test, let me explain that step by step here. So again, let me draw a bell shape, because we are talking about the standard distribution, standard normal distribution. Now the alpha, which is 0.05, this time needs to be shared in two tails. So therefore, each tail will be half of the 0.05, which means 0.025. 0.025. Now you just they're symmetrical with respect to 0, so if you find one, you can find the other one. So you use one of those tails and then find this value in StatsCrunch. Let me give a try. So let's give a try. So in this case, to the right side is 0.025. I get the 1.96, right? Okay, so in this case, both tails are rejection region. If your test statistic falls in here, you reject HO. If your test statistics falls into the middle region, you fail to reject HO. If your test statistic falls in this region, you still reject HO. So this is the traditional method, how to find the critical value, how to determine the critical region or the rejection region. So that in my next video, I'm going to explain the p-value method